All right, let's jump right into this explainer and tackle something that, let's be honest, trips up a ton of geometry students. We're talking about transversals, parallel lines, and those tricky algebraic angle proofs. If you've ever stared at a geometry problem and felt completely, utterly lost, well, you are exactly in the right place.
Take a deep breath. Seriously, I know this stuff looks super tricky when you're just staring at a page full of intersecting lines and random algebraic variables. But hey, as your tutor today, we are going to build this step-by-step together until you absolutely master it. We're going to start with the bare-bones basics and work our way right up to those tough exam questions.
Let's start with an easy win, okay? What actually is an angle? Well, essentially, it's just an amount of rotation formed when two straight lines, or rays, meet at a common endpoint. We call that endpoint a vertex. And to measure that amount of rotation in degrees, we use a standard tool you've probably had in your backpack at some point, the trusty protractor.
Think of these next definitions as our foundational building blocks. Depending on their size, angles get special names. Acute angles are the little guys, anything between 0 and 90 degrees. A perfect right angle hits exactly 90 degrees. Obtuse angles open up a bit wider, sitting between 90 and 180 degrees. A perfectly straight line is exactly 180 degrees. And a reflex angle? That one bends even further, falling somewhere between 180 and 360 degrees.
Now, the real magic happens when we start pairing angles together. It's like a puzzle. When two angles perfectly sum to exactly 90 degrees, we call them complementary angles. But if they sum to exactly 180 degrees, creating a flat, straight line, we call them supplementary angles. Definitely memorize those two terms because they're the key to unlocking the whole shebang later on.
Let's test your visual skills with a quick little mental exercise. Imagine a typical intersection, kind of like a crossroad, where two perfectly straight lines cross each other. Take a second to picture it in your mind's eye. Can you spot the angles that are directly opposite each other across the center? How about the ones that are sitting right side by side along the same line?
So, here's the absolute crucial takeaway. Those angles directly across the intersection from each other are called vertical angles, and they are always completely congruent, meaning they have the exact same measure. Meanwhile, the ones sitting side by side sharing a line form what's called a linear pair, and they will always be supplementary. They inevitably add up to 180 degrees. All right, now that we've got our basics totally locked down, let's level up to the main event. Imagine taking two perfectly parallel lines. Lines that will literally never touch no matter how far they go into infinity. Now, slice a single diagonal line right through both of them. That intersecting line is called a transversal, and it creates a very specific, incredibly predictable pattern of angles. Whenever this specific geometric scenario pops up, you end up with a group of 4 angles at the top intersection, and a group of 4 at the bottom. The cool thing is, you really only need to remember 4 simple rules to figure out literally any missing number here. Rule 1. The top group and bottom group are completely identical. Rule 2. There are only ever 2 different angle measurements in the entire diagram. Rule 3. Those 2 different angles always add up to 180. And Rule 4. The vertically opposite ones are always exactly the same.
Okay, I get it. The geometry vocabulary can be a lot to juggle. Alternate interior, corresponding, consecutive. Yeah, it's super easy to get them all mixed up. So to keep you from getting lost in the complicated math jargon, we are going to rely heavily on a visual trick. We are going to look for the letters Z, F, and C hidden right there in the intersecting lines. If you were to trace a Z shape over those parallel lines, pay attention to the 2 inside corners of that Z. These are your alternate interior angles. They're on opposite sides of the transversal, but they're tucked safely inside the parallel lines. And the best part? They are always exactly equal to each other. Next up, we have the F shape. Trace the letter F along the lines and look at the matching corners neatly tucked right under the 2 horizontal arms. We call these corresponding angles. Because they sit in the exact same matching position at both intersections, they are also entirely congruent. They are the exact same size. Finally, picture a C shape.
This one outlines the consecutive interior angles, which are sometimes called allied or same-side interior angles. Now, here is where you have to pay attention. Unlike the Z and the F shapes, these two angles are not equal. Because they're boxed in on the same side, they are supplementary. They uniquely sum to exactly 180 degrees.
Let's take a quick real-world breather here. Because, you might be sitting there asking, why does this even matter outside of a math class? Well, it isn't just worksheet math. Architects and interior designers use these exact transversal rules every single day. As noted by the digital design platform Home, when arranging partitions in an open concept office, designers leverage these angle relationships to guarantee visual symmetry.
This goes to show that mastering this stuff is incredibly practical. Whether someone's using a digital space planner or drafting things out by hand on paper, understanding alternating and corresponding angles is absolutely essential for creating beautiful, balanced, and symmetrical room layouts. It literally dictates how lines of sight and structural elements align perfectly across a room.
All right, now that your confidence is up and you can see the real-world value, let's tackle the final boss of our tutorial, those intimidating exam questions. You know, the ones where, instead of just giving you simple numbers, the angles are expressed as tricky algebraic variables, like 7x minus 12.
Don't hit the panic button just yet. Just follow this foolproof 3-step guide. Step 1. Identify the relationship using those Z, F, or C tricks we just talked about. Step 2. Decide if they are congruent or supplementary and set up your equation based on that. And Step 3. Use basic algebra to solve for x. Come on, let's do a couple together.
Let's look at two super common scenarios you'll run into. In one scenario, say we have alternate exterior angles. Since they're alternate, we know they are congruent, meaning we simply slap an equal sign between them. So 7x minus 12 equals 3x plus 28. In another scenario, we might have same-side interior angles. We know those are supplementary, so we add them together and set them equal to 180. That gives us 3x plus 6x equals 180. Let's actually solve that first one. If 7x minus 12 equals 3x plus 28, well, we subtract 3x from both sides, which gives us 4x. Then we add 12 to the other side to get 40. So 4x equals 40, which means x equals 10. And if we plug that 10 back in, 7 times 10 minus 12 is 58, meaning both of those missing angles are exactly 58 degrees. Boom! You just solved an algebraic proof. And for that second scenario, our consecutive interior angles, 3x plus 6x gives us 9x, so 9x equals 180. Dividing 180 by 9 gives us x equals 20. Plugging that back in, 3 times 20 is 60, and 6 times 20 is 120. We have confidently calculated our missing 60 and 120 degree angles, and sure enough, they add up perfectly to 180. We did it!
You've officially mastered transversals and algebra proofs. High five. But before we wrap up this explainer, I want to leave you with a final, kind of mind-bending thought from Euclid, the ancient father of geometry himself. He figured out that if those inside angles on the same side add up to less than 180 degrees, those two lines are actually no longer parallel. They will inevitably crash into each other and intersect if you draw them out far enough. It really makes you wonder how slightly shifting just one angle changes the entire landscape of a geometric plane. Thanks for learning with me today, and keep looking for those angles in the world around you.
If you have learned something great today, please click in the subscribe button. Like, share to others. Thank you.